Hello friends, today we will start a new part of this lesson, that is scattering of light. What is scattering of light? That is a very important phenomena which helps us to see the light. When this light fall into the particle, the light spread around. That is actually the scattering of light is. Also we will study the Tyndall effect. What is Tyndall effect? Same with this is the one phenomena of scattering of this light. Now also we are going to see why the color of the clear sky is blue. But always there. You may not think about why this color is blue, whether there is such a blue envelope is there, what may be the reason of that. And also we will see the color of the sun at sunrise and sunset. You know that some red it is the color. What may be the reason for that? All these things we are going to see today. Okay, but the answer for all these three is one, that is scattering of light. So let us see what is scattering of light. Okay, this scattering of light means when the light passing from one medium to another medium, such as from air to glass, or it is like that. Then a part of that light is absorbed by the particle of the medium. This is very important. What? A part of the light is absorbed by this medium by subsequent radiation. Then what it will do is it radiates. It radiates means it emit. Radiation means emit. It emits that light from this. Then by the subsequent radiation in a particular direction. In a particular direction, then it is started to emit these absorbed lights. Now, while it is emitting this absorbed light, it may not be like that of it is absorbed. Understand? That is the entire that light may not be emitted. It may be emitted some colors. Sometimes it may be emitted the entire light. Understand? So, direction. This phenomena is termed as scattering of light. So, understand what is scattering of light? When the light passing from the one medium to another, such as air, glass, etc. Then the part of the light is absorbed by the particle of the medium. Then what it do is, then the subsequent radiation in a particular direction. This phenomena, which phenomena? This radiation phenomena, is termed as scattering of light. Here you study that in the last year. You may study this. That is when the light is passing through a clear solution and a solution which is having some particle, colloidal particle it is called. What is colloidal particle means? Some minute particles, is called the colloidal particle. So it is a pure water, but it is a salt water. When this light is passing through the pure water, you can see that you cannot see the path. Now here, in the salt solution you can see the path. Why it is so? So why you are seeing the path is this is what the due to scattering. Understand? That is also called the Tyndall effect. Now what is the Tyndall effect? Tyndall effect. Now this Tyndall effect means the path of the sun rays which we can see, that is the Tyndall effect actually. How we can experience this Tyndall effect while telling about, if we are in a closed room, and somewhere there is a hole in that room. Through that hole, if the light is coming inside the room, you can see that this light spread entire the room and the direction that a white line you can see, okay, through which the light is entered, in through which we can say this, especially the, okay, dust particles of moving here and there. No, that means the entire room is illuminated. Why? Because of the scattering of light, because of thread of the. Now, why it is so? Because of due to that dust particle and okay, other particle which is there in, that is even the gas particle. Okay, like that we can see. So here the Tyndall effect is. So what actually, how the Tyndall effect can be told about? The Earth atmosphere is a heterogeneous mixture of minute particle. Okay, now here the word you must understand is, okay, heterogeneous. Okay, what is heterogeneous? Okay, what is heterogeneous? Heterogeneous means, okay, here it is not homogeneous. That is, not homogeneous means it is heterogeneous. Okay, what is homogeneous? If the, okay, density of the particle or concentration of the particle is same everywhere, then we can say that it is a homogeneous, okay, solution or thing like that. Now, heterogeneous means the concentration of this particle may not be same everywhere. Somewhere the concentration may be more, sometimes the concentration may be less, like that it is. Okay, like that. So it is heterogeneous, it is called. So what is the Earth atmosphere is a heterogeneous mixture of minute particle. Okay, what is minute particle means? Anything can come here. Okay, that is, okay, there it can come gases, okay, it can come the water molecule, okay, etc. These particles include, yes, smoke, tiny water droplet, suspended particle, dust, okay, and a molecule of the air also. Okay, these are the, okay, this minute particles. Understand? Okay, then when a beam of light strikes such fine particle, the path of the beam become visible. That is what we see in the scattering of light. Understand? This you can see here in this picture. Okay, you can see here. Look, when the light entered, you can see this. You can see this. Okay, now this is what the scattering of light, that is the Tyndall effect. Okay, when the beam of light strikes such fine particles, which fine particles? That is of the air, okay, air molecules, that is gas, okay, and the dust, water molecule, etc. like that. Okay, the path of the beam become visible. Correct? This path of the beam is visible here. Here also it is visible like that. Okay, the light reaches us after being reflected diffusively by this particle. Yes. Okay, now you know that how the light reaches to us. Okay, through the reflection, you see. Now here the light is reflected, okay, diffusively. Diffusively means, or it is what the surrounding, okay, by these particles. Okay, there is a diffusion. Okay, then the phenomena of scattering of light by the colloidal particle gives rise to the Tyndall effect. So this is the Tyndall effect. Is understand? Which this phenomena of scattering of light by the colloidal minute particle, okay, gives rise to the Tyndall effect. So this phenomena is seen when a fine beam of sunlight enters a smoke filled room through a small hole. Okay, that is the example we see. Thus the scattering of light makes the particle visible. Yes, that is very important. Okay, that is this scattering of light makes the, okay, particle visible. Okay, that is why, okay, what we can say is, okay, the Tyndall effect is there. So what is the reason of Tyndall effect? Yes, already answer is one, the scattering of light. The second is how, what is the reason it is? Due to the, okay, colloidal particle. Okay, scattering of light due to colloidal particle gives rise to Tyndall effect. Very simply, if it is one sentence, one mark, okay, what define Tyndall effect? You can say the phenomena of scattering of light by colloidal particle gives rise to the Tyndall effect. That much you can write. Understand? Okay, so that is about the, I hope you understand it. Okay, so what is here important is, okay, when the beam of light strikes such fine particles, the path of the beam becomes visible. Understand? Okay, there the Tyndall effect is. So we can move. Okay, here it is. Other Tyndall effect we can see is, okay, in the forest. Okay, That is, you know that when you are seeing into the dense forest, okay, through a canopy of the dense forest, okay, here the tiny water droplet in the mist scatter the light. Here, okay, now in the room you see that the dust particle is there, smoke is there, but in the forest actually what is there? The tiny water droplets in the mist scatter the, they are the, okay, mist scatter the light, okay, water droplet, okay, scatter the light. Okay, the color of the scattered light depend on the size of the scattered matter. That is also very important. In the introduction I told that, okay, when it is scatters, okay, the color of the scattered light depends on the size of the scattering particle. Understand? That is, the scattering particle having some importance, okay, in the color it is. Okay, what is the look here? Okay, very important. It is very fine particle scatter mainly blue light. Understand? Very fine particle, very small particle. Okay, then okay, it is scatter blue light. Okay, while the particles of large size, okay, become scatter of the longer wavelength. That means we can say, now here you know that it is of a Vibgyor, correct? Okay, Vibgyor. So here this you know that these are the lower wave. Here up to here we can say it is of the lower wavelength, and here these are of the higher wavelength, we can say, correct? So here the fine particle scatter the, okay, what it is, the smaller wavelength, very fine but blue light. Okay, in a smaller wavelength means here we can say blue, indigo, violet, etc. So among that the prominent is, which is the prominent? Blue is the prominent. So blue is scattered. Understand? But the, okay, large size, okay, can scatter the, which here the yellow, orange and red, okay, etc. The size of the scattering particle is large enough, then the scattered lights may even appear white. If it is very large, like that of, okay, what we can say, cloud, okay, cloud appears white. Why? Because it is so large enough that, okay, it appears to be, that is, it emit all the, what it is emit? It emit all the rays, so that we can see it is of white only. Understand? So, okay, then we will move to the other. Here it is, okay, why is the color of the clear sky blue? Okay, here again the answer already you have. Okay, that is because of the scattering. Answer is, simple sentence. The question is, why is the color of the sky sky blue? Answer is because of the scattering of light. Understand? Because of the scattering of light. How it is, you see. Okay, so now here we can see a video, okay, from that. Okay, you will understand it. Okay. Okay, now while telling about, okay, here yes, these are the, okay, shorter wavelength, okay, rays of shorter wavelength, that is violet, okay, indigo, okay, blue. Look, you can compare this. Okay, among these, which is more, blue is prominent, okay, and indigo. Now these green, yellow are the higher wavelength. Okay, now here, yes, atmosphere is having, but it is gas, dust particle, water droplets, etc. Now, among these gases, you know that, okay, what is there? Nitrogen is the prominent gas, okay, and other is oxygen, then the inert gas, that is of inert gas, that is of argon, okay, xenon, etc., carbon dioxide, etc., like that. Okay. Now, when the light pass through this atmosphere, these small gas molecule, that is air particle, okay, what we do, it absorb the sunlight and remit it to various direction. That is, we see scattering. This is what the process of scattering we can say. Rayleigh law of scattering is there. Okay, actually it is not for your, okay, in higher standards you study about it. Okay, that is intensity of the scattered light is inversely proportional to the fourth power of the wavelength of this wave. From this one thing you can understand that the intensity is inversely proportional to the fourth power of the wavelength. That is, as the wavelength, okay, decreases, what will increase? The intensity will increase. That is, intensity increase, okay, that means okay, wavelength increases, then the scattering will be less. Understand? Here the I is the intensity of the scattered light. Okay. Okay, so that here you can see, okay, which will be the more, here you know that, okay, here the lambda increases, that is wavelength is increases, then the scattering will be, okay, less. So which among this, which will be the less scattered? Red will be the less scattered, correct? Okay, and which is the more scattered? Violet will be the more scattered. Okay, it is like this. Yes. Okay, this will be the most scattered. Okay, among that, okay, which reaches to our eye is blue reaches to our eyes. Understand? The other is scattered off. Now, whichever the light, whichever the color reaches to us, okay, that is what we see. So violet do not reaches to us. Okay, then okay, it does not reaches to our eyes, therefore it cannot be seen. This is the solar spectrum. We can see from here, yes, blue. Okay, then here the violet. So violet is scattered. Okay, it is less scattered, so it reaches to our eyes. So we can see that. That is human. Okay, eyes more the sensitive to the blue. Yes, that's about the gas. While telling about the dust particle, you know that the particle size is very large, so that okay, we cannot okay see the colors there. Then what we can say? We can see the white light only. Okay, so it because it emits the entire okay light, so that we can see the white only. So the cloud become white. Understand? So that is about it. Now you see here. Okay, now we can see that. Okay, look here, the molecule of the air and the other fine particle in the atmosphere have the size smaller than the wavelength of light, visible light. Understand? Smaller particle, that is very important on how the size, okay, the particles, the fine particle, the molecule of the air and other fine particle in the atmosphere have a size, what its size is smaller than the wavelength of visible light. Understand? Visible light having some wavelength. Now the this fine particles, the size is less than that of the wavelength. Sure. So these are more effective in scattering light of shorter wavelength. See, these are these fine particles are okay more effective in scattering light of shorter wavelengths at the blue end, okay, than light or the longer wavelengths at the red end. Yes. Okay, so these, that is especially we see there that if it is the fine particle, okay, it can scatter the light, okay, that is the lower wavelength, that is of blue, violet, indigo, etc. Understand? Not that of the higher wavelength. Okay, then okay, and in the shorter wavelength at blue, yes, which is shorter wavelength is blue, it is of okay, then the end than the light of longer wavelength. So the longer wavelength will not be scattered. Which will be scattered? Only the shorter wavelength, up to which, up to the blue. Okay, now the red light has wavelength about 1.8 times that of the blue light, that is almost double, we can say. Okay, thus when the sunlight passes through the atmosphere, okay, the fine particles in the air scatter the blue light, that is shorter wavelength, more strongly than the red. Understand? More strongly than the red. The scattered blue light enters our eyes, so we see the sky blue. Understand? Understand? So whichever the light which enters our eye, that is what we see. Okay, so which light enters our eye? Okay, blue enters our, so we see it as blue. Okay, it is not like that always the sky is blue. No, in the during the morning and evening, sunset and sunrise. Okay, we know that. Okay, the atmosphere, that is the sky, is somewhat reddish. Okay, especially the horizon is. Okay, why? Because the more scattering. Okay, there the scattering of, okay, even the red is scattered. Okay, that we will see there. Okay, that is what here. Okay, the color of the sun at sunrise and sunset. Okay, now here the same reason. Now you see, now we know that normally initially which lights are scattered. Now blue light, up to blue light is scattered to a certain distance. Understand? Now when it travel more distance, okay, it started to scatter the other light also. That means, okay, other means up to blue, after blue, okay, it is green, yellow, orange, red, it is like that. Okay, so among that which is very prominent is red, you know that. Okay, so that so here when it is traveling for long distance, okay, blue, then rest of the light also started to scatter. Understand? So that, okay, when it is traveled more distance, which light will be seen? Okay, only the light, okay, the light which enter in our eyes is of red, so that we can see the red. Okay, now here look, the color of the sun at sunrise and sunset. Light from the sun near the horizon passes through the thicker layer of air. Understand? Here it is, thicker layer of air, and a large distance in earth atmosphere before reaching our eyes. Understand? Before reaching our eyes, okay, it passes through a thicker layer of air as well as the larger distance in the earth atmosphere. Understand? So here the air is shorter, and here it is of a larger distance. Understand? Now the light from the sun, or however the light overhead, would travel, okay, relatively shorter distance, but it is relatively shorter distance. Understand? Okay, then at noon the sun appears white, as only the little blue and violet colors are scattered. Yes, okay, during the noon, you know that the distance is very less, so that we can see it is of white, because, okay, very little violet or blue light is of scattered. Okay, but okay, at okay, near the horizon, okay, most of the blue color and short wavelengths are scattered, okay, away by the particles. Understand? Everything is scattered away. Therefore, the light that reaches our eye is of longer wavelength, which one only will reach, okay, only longer wavelength only will reach. Now, one thing you understand, that someday it is possible that, okay, why we can't see it as green, why it is of like that. Okay, now look, among that other wavelength which is prominent. Now, for example, violet, indigo, blue, among that which is prominent, okay, blue is prominent, so we can say blue. The rest of it which is prominent, okay, that is, okay, red is prominent, that is which we reaches to our eyes, so that, okay, we can see, okay, that red it is. Okay, and you know that the sky at that time, the surrounding place also, it is of red, we can see. Understand it? So the two reasons for it is, one is of it is passes through thick layer of air. Understand? One reason is of it passes through thick layer, and other is of it travel large distance. So, okay, which only reaches to our eyes. Okay, here that is the, okay, the light that reaches to our eye is longer wavelengths, that is red in the reddish appearance of the color. Sure, all of you, very important it is. It can ask for the short note, give reason, etc. like that. Okay, then we will move to the, okay, last part, that is of if the earth had no atmosphere. Okay, yes, if it had that no atmosphere. No atmosphere means you know that what it is. Okay, it is a space. Now how the space will look like, whether it is a violet color, is it so? No. Okay, space, there is no particle, therefore there is no scattering, therefore everything will be dark. Look, even though the sunlight passing through the space, okay, we cannot see the, but we cannot see the sunlight there in the space. Why? Because there is no particle to scatter it. Now, so that now we can see around because of this scattering phenomena actually. Getting? Okay, now scattering because of the particles are there. Okay, gas is there, dust particle is there. Okay, it is like that. So, if the earth had no atmosphere, there would not have been any scattering. Sure? Okay, then the sky would have looked dark. How to look dark? Sky look dark. From that, one more thing we can, what is the color of the, okay, space? Okay, there you will see only dark. Sure? Why there is only dark? Because there is no atmosphere. Now, the sky appears dark to the passengers while flying at the very high. That is also very high altitude if it is passing. Okay, then for the passengers, what it will look dark, as the scattering is not prominent. Okay, at such heights. Understand? Because at higher heights. Okay, because the very less gas molecules are there, so that the scattering is not prominent. Understand? So that what only there they can look that around is dark. You might have observed the danger signal. Now one more give reason here it can ask. Okay, give reason. Okay, that is so the danger signal of, okay, light are red in color. You know that, okay, danger signal is right. Okay, and let's go, and it is the, yes, you can go. Okay, like that it is. Okay, get ready and go. Okay, correct. These are the stop, get ready, and go. Okay, why these colors are using? Now here while telling about these colors are, you know that it is of a longer wavelength. These lights having the longer wave. If it is having the longer wavelength, okay, then obviously we can say that the scattering will be minimum. Correct? Because no the longer wavelength do not scatter. Okay, so that from long distance also we can see these colors clearly. Understand? That is the reason why. Okay, danger, why the danger is red? Because we know that the danger is the, okay, the longest wavelength, having the longest wavelength. Okay, so its scattering is minimum. So very long distance we can, okay, see the red color. Understand? But that much not there the yellow and green. Okay, so the danger is used for, okay, signal is used as, okay, red color. So we can see it, because that is very important. Stop, the danger is there. Okay, that is to come to know is very important. Understand? Okay, that's why it is. Now the red is the least scattered by the fog, smoke, etc. Okay, therefore it can be, okay, seen in the same color the distance. So give reason it can. So you can see that it is having the, one more point you can add is, it is having the longest wavelength. So its scattering is very minimal. Understand? Okay, that also you can include in it. So I hope, okay, you understand all this concept. Okay, practice well, read the textbook. Okay, fine. Thank you very much.